On the morning of March 17, 1944, in the fog-shrouded hills of central Italy, Private First Class Marcus Washington stood before a makeshift table in a canvas tent, watching three white officers examine a small burlap sack as if it contained either genius or madness. The temperature hovered just above freezing. Hand condensation dripped from the tent's sagging roof onto maps spread across wooden crates. Outside, the distant rumble of artillery created a rhythm that every soldier had learned to sleep through, a percussion of war that never quite stopped. What none of these men knew, as they debated whether to approve the most unconventional sabotage proposal of the Italian campaign, was that this moment would fundamentally change not only the outcome of an entire offensive, but also the way military engineers thought about unconventional warfare for the next 8 decades. The officers believed they were simply reviewing another desperate suggestion from the enlisted ranks, the kind of wild idea that surfaces when conventional approaches have all failed. They would soon discover they were catastrophically wrong. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. This is the story of how a 23-year-old soldier from Detroit, armed with nothing more than industrial soap powder and an understanding of chemistry that the military had never bothered to document in his file, accomplished what 3 previous commando raids and 2 bombing runs had failed to achieve. It is a story about the intersection of prejudice and genius, about how the most powerful weapon in war is sometimes not firepower, but imagination, and about how a man who was never supposed to be anything more than a support soldier became the architect of one of the most creative acts of sabotage in the Second World War. Marcus Washington had arrived in Italy 5 months earlier as part of the 677th Quartermaster Truck Company, one of hundreds of segregated African-American units that kept the Allied war machine running while receiving almost none of the recognition. He was not supposed to be anywhere near combat operations. His job was to drive supply trucks along treacherous mountain roads, delivering ammunition, food, and fuel to forward positions, while white infantry units received the glory of advancement and liberation. The Army's official position was clear. Black soldiers were suitable for labor and transportation, but not for the complexities of combat or technical operations. This assumption, like so many others that spring, would prove to be remarkably expensive. The bridge that had become the obsession of Allied command sat in a ravine approximately 40 kilometers behind what remained of the German defensive positions south of Bologna. It was not a particularly impressive structure by engineering standards, just a reinforced concrete span roughly 30 meters long, stretching across a seasonal river that, in March, ran swift and cold with snowmelt from the Apennines. But this bridge carried something far more valuable than its own weight. Every night, under cover of darkness, German supply trucks crossed this span carrying ammunition, fuel, and food to forward positions that were holding up the Allied advance. Intelligence estimates suggested that 70% of supplies for the entire central sector passed over this single bridge. Destroy it, and you could starve out 3 divisions. Leave it standing, and the stalemate would continue indefinitely. The problem was that the bridge was essentially untouchable by conventional means. It sat in a narrow ravine with steep sides that made ground assault nearly suicidal. The German forces had positioned machine gun nests on both approaches and maintained constant patrols along the ridgelines. 3 commando raids had been attempted over the previous 2 months. The first team never made it within 500 meters of the target. The second team reached the bridge, but was discovered before they could place their explosives. Only 1 man from that group made it back to Allied lines. The third attempt used a different approach, trying to come down the river itself, but the current proved too strong, and the team was swept 3 kilometers downstream where they were captured. As for aerial bombardment, the ravine's geography made accurate bombing nearly impossible. 2 attempts had been made with heavy bombers, but both times the bombs had missed the bridge entirely, instead cratering the surrounding hillsides and actually making the German defensive positions stronger by providing ready-made bunkers. By mid-March, the bridge had achieved a kind of mythical status among Allied planners. Some called it the Devil's Span. Others simply referred to it as the Impossible Bridge. The Fifth Army's Chief of Staff had reportedly said he would give a month's pay to anyone who could figure out how to drop that bridge without losing another man. It was against this backdrop of frustration and stalemate that Marcus Washington made his proposal. The idea had come to him not in a moment of tactical brilliance, but during one of the most mundane activities of military life. He had been washing his uniform in a cold stream, using the harsh industrial soap powder that the Quartermaster Corps issued in bulk. As he scrubbed at oil stains from working on truck engines, he noticed how the soap reacted with the mineral-heavy water. It foamed aggressively, creating bubbles that seemed to multiply exponentially. More interestingly, when the soapy water flowed over rocks, it left behind a slippery residue that took hours to wash away naturally. Marcus had stood there, hands numb in the frigid water, watching soap bubbles float downstream, and something in his mind had clicked. Before the war, Marcus had worked for Detroit Industrial Chemical Company, a manufacturer of cleaning supplies that sold products to automotive factories. His official job title had been warehouse assistant, but that bland description concealed the real education he had received. The company's head chemist, a German immigrant named Dr. Hermann Kleist, who had fled Germany in 1938, had taken an interest in Marcus after discovering that the young man could perform complex calculations in his head and had an intuitive understanding of chemical reactions. For 2 years, Dr. Kleist had mentored Marcus unofficially, teaching him industrial chemistry during lunch breaks and after hours. They had developed several new formulations together, including an industrial degreaser that the company still sold under Dr. Kleist's name alone. When Marcus had registered for the draft in 1942, Dr. Kleist had written a letter to the draft board explaining Marcus's technical expertise and suggesting he could be valuable in chemical warfare or engineering roles. The letter had been filed away and forgotten. The Army saw a black man from Detroit and assigned him to drive trucks. But that chemical education had not been forgotten by Marcus himself. As he watched the soap bubbles in the stream, his mind raced through calculations and possibilities. Industrial soap powder, the kind the Army used by the ton, contained sodium carbonate and sodium silicate along with various surfactants. When mixed with water, these compounds created an alkaline solution. When that solution came into contact with certain types of stone and concrete, especially the limestone-heavy concrete that German engineers favored for rapid field construction, it initiated a slow but inevitable process of chemical erosion. The surfactants reduced surface tension, allowing the solution to penetrate deep into microscopic cracks and pores in the concrete. The alkaline compounds then reacted with the calcium compounds in the concrete, gradually breaking down the material's structural integrity. It was a process that usually took months or years to cause significant damage, which is why industrial soap was generally safe to use around concrete structures. But Marcus had learned something else from Dr. Kleist, something about accelerating chemical reactions through manipulation of concentration, temperature, and mechanical stress. If you could get enough of the right soap solution into the right places in a concrete structure, and if that structure was already under significant mechanical stress, and if you could maintain the chemical reaction over a period of days rather than months, you could theoretically weaken the structure enough to cause catastrophic failure. The bridge in the ravine was under constant stress from the weight of heavy supply trucks. The March snowmelt had raised the river level, adding water pressure against the pilings. The concrete was already showing cracks from previous bombing attempts that had missed the bridge but rattled it with nearby explosions. All the conditions were there. The bridge was, in chemical terms, already vulnerable. It just needed the right push. Marcus had spent 3 days refining his idea before bringing it to anyone. He requisitioned old supply manifests and studied exactly what kind of soap powder the Quartermaster Corps had in stock. He drew diagrams in a battered notebook, calculating concentrations and reaction times. He performed small-scale experiments in empty tin cans, mixing soap powder with samples of concrete rubble from destroyed buildings, timing how long it took for the alkaline solution to cause visible deterioration. The results were promising but not definitive. What he was proposing had never been attempted before, at least not as far as he knew. It was the kind of idea that could work brilliantly or fail spectacularly. The question was how to get anyone to listen. Marcus was painfully aware of his position in the military hierarchy. He was a private first class in a truck company. He was black in an army that still maintained rigid segregation and assigned black soldiers almost exclusively to support roles. He had no formal technical credentials that the army recognized. If he went through official channels, his proposal would be dismissed before it reached anyone who mattered. He needed an advocate, someone with enough rank to get a hearing, but unconventional enough to take the idea seriously. He found that person in Captain James Thornton, the white officer in charge of coordinating supply deliveries to forward engineering units. Thornton was a 31-year-old civil engineer from Boston who had spent the 1930s building bridges for the Works Progress Administration. He had a reputation for being more interested in getting things done than in maintaining social conventions, which had made him unpopular with some of the more traditional officers, but effective at his job. Thornton had noticed Marcus before, mainly because Marcus was the only driver who consistently delivered supplies ahead of schedule and always seemed to know the optimal routes through the chaotic Italian road network. When Marcus requested a private meeting, Thornton was curious enough to agree. The conversation took place in Thornton's tent on a cold evening, with rain drumming on the canvas overhead. Marcus had prepared carefully, bringing his notebook filled with calculations and diagrams. He began by acknowledging the unusual nature of his proposal and his own lack of official credentials. Then he launched into his explanation, walking Thornton through the chemistry of concrete degradation, the specific vulnerabilities of the bridge based on intelligence reports, and the detailed plan he had developed. He spoke for nearly 20 minutes without interruption, covering everything from the required concentration of soap solution to the optimal placement points to the timeline for structural failure. When he finished, Thornton sat in silence for a long moment, studying the diagrams. Then Thornton said something Marcus had not expected. He said, "Where did you learn all this?" Not in a dismissive way, but with genuine curiosity. Marcus explained about Detroit Industrial Chemical, about Dr. Kleist, about the 2 years of informal education in industrial chemistry. Thornton listened, nodding slowly. Then he asked the questions that mattered. "Do you really think this can work? What is the probability of success? What do we need to make it happen?" Marcus answered honestly. He thought there was a 60 to 70% chance of success if they could deliver the soap solution correctly and maintain the chemical reaction for 5 to 7 days. They would need approximately 800 pounds of industrial soap powder, a delivery system to get it into position around the bridge's support structures, and time for the reaction to work. They would also need luck, because if German engineers inspected the bridge closely during those 5 to 7 days, they might notice the chemical attack and take countermeasures. Thornton considered this for another long moment. Then he made a decision that would change both their lives. He told Marcus to give him 48 hours. He was going to take this up the chain of command, but he was going to present it as his own plan initially because, and here Thornton was brutally honest, no one would take it seriously coming from a black private. Once he had buy-in from the command staff, he would make sure Marcus got credit and involvement. It was an imperfect solution that reflected the imperfect world they lived in. But it was pragmatic. Marcus agreed. The next 48 hours were among the longest of Marcus's life. He continued his normal duties, driving supply trucks through mountain roads, but his mind was constantly running through scenarios. What if they rejected the plan? What if they accepted it but kept him out of the execution? What if it failed, and he was blamed? He had stuck his neck out in a way that could easily destroy what little career he had in the army. But he had also seen too many men sent on suicide missions against that bridge. If his idea could save lives and help end the stalemate, it was worth the risk. Thornton moved quickly through the command structure, starting with the engineering battalion commander and working his way up. The initial reaction was skepticism. Chemical attack on concrete sounded like something from a science fiction novel, not a practical military operation. But Thornton had done his homework. He brought in a chemical officer who confirmed that the basic chemistry was sound, even if the application was unprecedented. He pointed out that the plan required no soldiers to approach the bridge directly, eliminating the casualty risk that had doomed previous attempts. He emphasized the minimal resource requirement compared to another bombing raid or commando operation, and crucially, he framed it as an experiment. If it failed, they had lost only 800 pounds of soap powder and a week of time. If it succeeded, they solved a problem that had stalled an entire offensive. The briefing that Marcus witnessed on the morning of March 17th was the culmination of Thornton's advocacy. Present were Colonel Richard Havisham, commanding officer of the Engineering Battalion, Major Frank Mitchell from Intelligence, and Captain David Schneider from the Chemical Warfare Service. Thornton had arranged for Marcus to be present, but had advised him to speak only when directly addressed. The social dynamics of a segregated army meant that Marcus's presence alone was unusual. Having him actively participate in tactical planning would stretch credibility with some of the officers present. Colonel Havisham was a career Army engineer, 52 years old, who had built fortifications in the Philippines before the war. He was old school in many ways, but had a reputation for pragmatism. He examined the burlap sack of soap powder that Thornton had placed on the table, then looked at the maps showing the bridge's location and the proposed delivery approach. His first question was direct. "Captain Thornton, you are telling me that you want to take down a concrete bridge with laundry soap. Is that an accurate summary?" Thornton explained patiently that it was not laundry soap, but industrial-grade soap powder with specific chemical properties, and the plan was not simply to dump soap on the bridge, but to introduce a concentrated alkaline solution into the structure's support points, where it would initiate a chemical reaction that would degrade the concrete's structural integrity over several days. Havisham listened, his face unreadable. Then he turned to Captain Schneider. "Is this chemically feasible?" Schneider, who had reviewed Thornton's documentation, nodded. "The chemistry is sound, sir. Alkaline attack on concrete is a well-documented phenomenon. The question is whether we can achieve sufficient concentration in the right locations to cause catastrophic failure in the proposed time frame. That part is theoretical." There was a brief silence. Major Mitchell spoke up. "What is the delivery mechanism? How do you get 800 pounds of soap powder into the river without the German forces noticing and investigating?" This was where Thornton's plan became creative. The German forces had grown accustomed to seeing debris floating down the river. The previous bombing attempts had knocked trees and vegetation into the water, and the spring flooding was washing all kinds of material downstream. Thornton proposed using waterproof containers, roughly the size and appearance of logs, filled with soap powder designed to slowly dissolve and release their contents over the course of 12 to 18 hours. They would be released into the river approximately 8 kilometers upstream, well outside the German security perimeter. By the time they reached the bridge, they would appear to be nothing more than flood debris. Timing the release for nightfall would minimize the chance of visual detection. The containers would be designed to lodge against the bridge's pilings and support structures, where they would slowly leak their contents into the water flowing around the concrete. Over the course of several nights, they would introduce approximately 800 pounds of industrial soap powder directly into contact with the bridge's most vulnerable structural points. Havisham studied the maps again, tracing the river's course with one finger. "What prevents these containers from simply floating past the bridge?" Thornton was ready for this question. "Weight distribution, sir. The containers will be designed with ballast that causes them to float low in the water and catch on any obstruction. We have observed that debris tends to accumulate against the bridge pilings due to the current dynamics and the bridge's design. We are simply mimicking natural debris patterns." Mitchell asked about German reactions. "Even if they do not suspect sabotage, will they not clear the debris as a matter of routine maintenance?" Thornton acknowledged this was a risk, but intelligence suggested that the German forces had limited manpower at the bridge and were focused on security against direct attack rather than maintenance. The previous bombing attempts had left considerable debris in the river that had not been cleared, suggesting that routine maintenance was not a priority. Still, this was one of several uncertainties in the plan. Havisham sat back in his chair, thinking. Then he asked the question that mattered most. "Captain Thornton, what is your assessment of probability of success?" Thornton hesitated, then decided on honesty. "Sir, I assess 60 to 70% probability that we can successfully deliver the chemical agent. I assess 50 to 60% probability that the chemical attack will degrade the bridge structure significantly. I assess approximately 40% probability that the bridge will fail catastrophically within the 7 to 10 day time frame." These are estimates based on theoretical chemistry and incomplete intelligence about the bridge's current structural condition. The numbers hung in the air. 40% sounded low, but everyone in the tent knew that the previous commando raids had achieved exactly 0% success while costing numerous casualties. Major Mitchell voiced what everyone was thinking. "Colonel, our alternative is another ground assault that intelligence estimates has less than 20% success probability with guaranteed casualties. Or we continue the status quo and accept that our offensive remains stalled indefinitely. 40% probability of success with 0 casualties and minimal resource expenditure seems worth attempting." Havisham looked around the tent, gauging reactions. Then his gaze settled on Marcus, who had been standing quietly near the tent entrance. "Private, step forward." Marcus approached the table, his heart pounding. Havisham looked at him directly. "Captain Thornton has explained that you were instrumental in developing this plan. Is that accurate?" Marcus chose his words carefully. "Sir, I provided the initial concept based on my background in industrial chemistry. Captain Thornton developed it into an operational plan." Havisham's eyes narrowed slightly. Industrial chemistry. Where did a truck driver learn industrial chemistry? Marcus explained briefly about Detroit Industrial Chemical and Dr. Kleist. Havisham listened, then asked a technical question that was clearly designed to test Marcus's actual knowledge. "If the water temperature is close to freezing, will that affect the reaction rate?" Marcus answered without hesitation. "Yes, sir. Cold water will slow the reaction significantly. However, the prolonged contact time compensates for the reduced reaction rate. Additionally, the friction from the river current creates localized temperature increases around the pilings that will help maintain the reaction. Ideally, we want water temperatures between 5 and 15 degrees Celsius. The current conditions are within that range." Havisham nodded slowly, satisfied that Marcus actually knew what he was talking about. Then he made his decision. "All right, Captain Thornton. You have approval to attempt this operation. You will have 5 days to construct your devices and initiate the delivery. Private Washington will be temporarily assigned to your unit as a technical advisor. He will be directly involved in the construction and deployment. Captain Schneider, you will provide oversight to ensure chemical safety. Major Mitchell, coordinate with intelligence to monitor German activity around the bridge. We will give this 1 week after initial deployment. If we do not see structural failure by then, we proceed with planning for a conventional assault. Understood?" Everyone acknowledged their orders. As the meeting broke up, Havisham pulled Marcus aside briefly. "Private, I do not care what color you are or what your job classification says. If you have expertise that can help win this war, you contribute that expertise. Make this work." Marcus saluted. "Yes, sir, I will do my best." Over the next 4 days, Marcus became part of a small team working in a secluded supply depot away from the main camp. Besides Marcus and Thornton, the team included Corporal Anthony Russo, an engineer from Pittsburgh who had worked in construction before the war, Private First Class Samuel Chen, whose family ran a shipping business in San Francisco and who knew everything about waterproofing containers, and Sergeant William Hayes, an ordnance specialist who understood how to work with timing mechanisms. Captain Schneider visited daily to monitor their work, though he quickly realized that Marcus understood the chemistry better than he did. The containers themselves were masterpieces of improvisation. They used wooden frames built to approximate the size and shape of logs typically found in the river, roughly 2 meters long and 25 centimeters in diameter. The frames were wrapped in canvas that had been waterproofed with a mixture of tar and wax. Inside, they packed the industrial soap powder in layers, separated by thin sheets of waxed paper. The key innovation was in the controlled release mechanism. Small holes were drilled through the canvas coating at strategic points, covered with thin layers of water-soluble material that would gradually dissolve once the container was in the water. As the covers dissolved at different rates based on the material used and thickness, the soap powder would begin to leak out slowly, creating a sustained release over 12 to 18 hours, rather than a single dump of material. Each container also had carefully placed ballast, iron bars positioned to make the container float low and front-heavy, increasing the likelihood that it would catch on obstacles rather than float past them. Chen insisted on testing each container in a water tank they constructed from a damaged water trailer. They would place a container in the water and time how long it took for the soap powder to begin leaking, ensuring consistency across all devices. Marcus monitored the water around the test containers, checking pH levels and observing how the soap dispersed in the current. He made adjustments to the concentration and packing density based on these observations. The work was tedious and physically demanding. They constructed 24 containers over 4 days, working from dawn until well after dark. The team developed an efficient assembly line process, with each person specializing in specific tasks. Russo built the frames. Chen handled waterproofing and ballast placement. Hayes installed the release mechanisms. Marcus supervised everything, checking calculations and making adjustments. Thornton coordinated with logistics to ensure they had materials and with intelligence to confirm timing. During this period, Marcus experienced something he had rarely encountered in the army, being treated as an equal contributor rather than subordinate labor. Russo asked his opinion on structural questions. Chen consulted him about waterproofing chemistry. Hayes wanted his input on timing mechanisms. It was what Dr. Kleist had promised him years ago when Marcus had doubted whether his education mattered in a world that would only see his skin color. "Knowledge is power," Dr. Kleist had said. "They can deny you credentials and opportunities, but they cannot take away what you know. Someday someone will need what you know badly enough to listen." Marcus had not fully believed it until now. On the evening of the 4th day, they had completed all 24 containers, each one packed with approximately 33 pounds of industrial soap powder. The plan was to deploy them in 3 waves over 3 consecutive nights. The first wave of 10 containers would be released on the night of March 21st. A second wave of 10 would follow on March 22nd. The final 4 containers would be held in reserve in case adjustments were needed based on observations of the first 2 waves. Each wave would be released at approximately 2100 hours, allowing the containers to reach the bridge area around midnight, when German patrols were at their lightest. The deployment site was chosen carefully, a point approximately 8 kilometers upstream from the bridge, where the river curved and deepened, allowing them to access the water without being visible from German observation posts. The team would use a truck from Marcus's own company to transport the containers to the deployment point. Marcus had volunteered to drive it himself, knowing the mountain roads better than anyone. Russo and Hayes would accompany him to help with the deployment. Thornton would coordinate from the command post, maintaining radio contact with forward observers who would try to monitor whether the containers successfully reached the bridge. The first deployment night, March 21st, was cold and moonless, exactly the conditions they wanted. Marcus drove the truck with headlights off, navigating by memory and starlight along a route he had scouted during the previous days. The truck bed carried 10 containers, lashed down and covered with canvas to appear like any other supply shipment if they were spotted. Russo and Hayes sat in the cab with him, tense and quiet. The drive took 90 minutes. Slow progress over rough roads, with the constant awareness that straying too far off course could take them into German-controlled territory. They reached the deployment point at 2000 hours, giving them time to prepare before the planned release. The site was a small clearing beside the river, screened by trees, and far enough from any established position that they were unlikely to be observed. Working quickly and quietly, they unloaded the containers and positioned them at the water's edge. Marcus checked each one, confirming that the release mechanisms were intact and properly sealed. At exactly 2100 hours, they began sliding the containers into the water one at a time, spacing them roughly 2 minutes apart to create some separation as they floated downstream. The containers entered the water with quiet splashes, bobbed for a moment as they found their equilibrium, then began drifting downstream with the current. In the darkness, they were nearly invisible, just vague shapes on black water. Marcus watched the first few disappear around the river bend, hoping that his calculations were correct, that the containers would float low enough to avoid detection, but high enough to stay off the river bottom, that the current would carry them to the bridge, that the release mechanisms would function as designed, that the chemistry would work as theoretically predicted. There were so many variables, so many things that could go wrong. But there was also the simple satisfaction of having done everything possible to make it work. They completed the deployment in 25 minutes, then loaded back into the truck and drove back to camp, again without lights, Marcus navigating by instinct and memory. They arrived back at the supply depot at 2300 hours. Thornton was waiting with Captain Schneider and Major Mitchell. Forward observers reported seeing what appeared to be debris floating past German positions near the bridge around midnight, but could not confirm whether these were the containers or natural debris. There was nothing to do now but wait for the second deployment the following night and hope that the chemical attack was proceeding as planned. The second deployment on March 22nd proceeded much like the first. Same route, same timing, same careful procedure at the water's edge. This time they released 10 more containers, again spacing them to avoid creating an obvious pattern. The night was slightly less dark with a thin crescent moon, which made Marcus nervous about visibility, but also allowed the forward observers to report more definitively that they had seen multiple objects lodge against the bridge pilings around midnight. That was encouraging. The containers were reaching their target. Back at the command post, Major Mitchell shared intelligence updates. The German forces had not shown any indication of unusual activity around the bridge. No increase in patrols, no sign of engineering inspections, no indication that they suspected anything unusual. That was exactly what they wanted. The chemical attack was silent and invisible, working slowly beneath the water surface where no one would think to look. Now came the hard part, waiting. Marcus returned to his regular duties with the truck company, though Thornton had arranged for him to be available for consultation as needed. The plan called for 5 to 7 days for the chemical reaction to sufficiently weaken the structure. That meant they would not know whether the operation had succeeded or failed until approximately March 27th at the earliest. During that time, the bridge would continue carrying German supply convoys every night. Allied Command had decided not to attempt any other action against the bridge during this period to avoid alerting German engineers that something unusual was happening. Marcus found the waiting almost unbearable. Every day he wondered whether the containers had worked, whether the soap solution was penetrating the concrete as calculated, whether the chemical reaction was proceeding at the right rate, whether he had missed some crucial variable that would doom the entire operation. He had no way to check his work, no way to verify that anything was happening. He drove his supply routes, maintained his trucks, and tried not to think about the 40% probability of success that Thornton had quoted to Colonel Havisham. That meant 60% probability of failure. Better odds than a commando raid, but still a likelihood that his big idea would turn out to be nothing more than 800 pounds of soap powder floating down a river for no purpose. On March 24th, 3 days after the first deployment, Major Mitchell reported something interesting. German radio traffic near the bridge had increased slightly, with several messages referring to maintenance issues and structural concerns. Intelligence could not determine the exact nature of these concerns from the intercepted messages, but the fact that German engineers were suddenly interested in the bridge's condition was potentially significant. Was it possible that they had noticed something but not understood what they were seeing? Marcus allowed himself a small measure of hope. On March 26th, 5 days after the first deployment, forward observers reported that German truck traffic across the bridge had slowed significantly. Convoys that normally crossed at speed were proceeding cautiously, sometimes stopping midway across. That was a strong indication that German engineers had identified structural problems. The question was whether those problems were severe enough to cause catastrophic failure, or merely serious enough to require reinforcement and repair. The answer came on March 27th at 1400 hours. Marcus was performing maintenance on a truck engine when Corporal Russo came running across the supply depot, shouting his name. "Marcus, Captain Thornton needs you at headquarters immediately." It worked. The bridge is down. Marcus dropped his tools and ran, his heart pounding. Russo ran with him, both of them covering the quarter-mile to headquarters in record time, despite the muddy ground. The command post was chaos when they arrived. Officers crowded around maps and radios, voices overlapping with excitement and urgency. Thornton saw Marcus enter and pushed through the crowd to reach him. Private Washington, as of 1100 hours today, the bridge no longer exists. German engineers had stopped convoy traffic early this morning to inspect structural concerns. At approximately 10:45, while engineers were on the bridge conducting their inspection, the center span collapsed into the river. Early reports indicate the collapse was sudden and catastrophic. The bridge is completely impassable. Intelligence estimates it will take German forces a minimum of 4 to 6 weeks to construct a replacement crossing. Marcus felt his knees go weak with relief and disbelief. It had worked. His ridiculous idea with soap powder had actually worked. Around him, officers were already discussing how to exploit the German supply line disruption, talking about accelerating the offensive timeline, repositioning units to take advantage of the German forces' suddenly precarious logistics situation. But Marcus was focused on a different detail. He asked Thornton, "You said German engineers were on the bridge when it collapsed?" "Yes," Thornton confirmed. Aerial reconnaissance suggests there were approximately 6 to 8 personnel on the bridge at the time of structural failure. Their status is unknown. That sobering thought cut through Marcus's elation. He had been so focused on the chemistry and the engineering challenge that he had not fully considered that his success might mean people falling into a river as a bridge disintegrated beneath them. War demanded these trade-offs. The bridge had been facilitating operations that had already resulted in numerous casualties on both sides. Its destruction would save Allied lives and potentially shorten the war. But Marcus could not help thinking about those engineers, likely just doing their jobs, checking on structural concerns that they probably did not understand, who had been standing in exactly the wrong place at exactly the wrong moment. He reminded himself of the commando raids that had failed with their own casualties, of the soldiers who would not have to assault German positions that could no longer be supplied. This was better than the alternatives, but that did not make it simple. Colonel Havisham arrived at the command post an hour later and called for everyone's attention. "Gentlemen, I have just received confirmation from 5th Army headquarters. Aerial reconnaissance and signal intelligence confirm that the bridge is destroyed beyond immediate repair. More significantly, German radio traffic indicates complete surprise and confusion about the cause of failure. Their engineering assessment attributes the collapse to structural defects possibly exacerbated by previous bombing damage and spring flooding. They have no indication that this was a deliberate act of sabotage. That means our operation remains undetected, which provides us with significant advantages," Havisham continued. "I want everyone involved in this operation to understand that you have accomplished something remarkable. You identified a critical vulnerability, developed an unconventional solution, executed it effectively, and achieved strategic results with zero friendly casualties and minimal resource expenditure. This is exactly the kind of thinking we need more of. Captain Thornton, you will prepare a complete after-action report for submission to Army headquarters. I anticipate that this methodology will be of significant interest to engineering and chemical warfare planners. Private Washington, step forward." Marcus approached, uncertain what to expect. Havisham looked at him directly. "Private, Captain Thornton has explained your central role in developing this operation. Your technical knowledge and innovative thinking directly contributed to a significant tactical success. I am submitting a commendation for your service and recommending you for immediate promotion to corporal. Additionally, I am requesting that you be permanently reassigned to the engineering battalion as a technical specialist. Your talents are wasted driving supply trucks. Do you have any objection to this reassignment?" Marcus could barely process what he was hearing. Promotion, reassignment to engineering. These were opportunities that black soldiers were rarely offered in 1944. He found his voice. "No, sir, no objection. I would be honored to serve wherever I can be most useful." Havisham nodded. "Good. Make it happen, Captain Thornton. Dismissed." As Marcus left the command post, Russo clapped him on the shoulder. "Corporal Washington has a nice ring to it. How does it feel to be a military genius?" Marcus shook his head, still processing everything. "I am not a genius. I just paid attention to my chemistry lessons." Russo laughed. "Well, your chemistry lessons just changed this whole campaign. The officers are already planning offensive operations based on German supply problems. You might have just shortened the war by weeks or months." The full implications of the bridge collapse became clear over the following days. German forces in the central sector, suddenly cut off from 70% of their supplies, were forced to withdraw to more defensible positions with better logistics support. This retreat opened up opportunities for Allied advances that had been impossible before. Over the next 3 weeks, Fifth Army forces advanced nearly 40 kilometers, liberating several towns and capturing substantial numbers of prisoners. The offensive that had been stalled for months suddenly had momentum again, and it all traced back to 800 pounds of soap powder and an understanding of alkaline chemistry. Marcus's promotion and reassignment were processed with unusual speed. Within a week, he was officially Corporal Washington, assigned to the engineering battalion as a technical specialist. His new role was to consult on demolition and sabotage operations, particularly situations where conventional approaches were impractical. It was work that utilized his chemical knowledge in ways the Army had never anticipated when they assigned him to drive trucks. He continued to face the reality of a segregated military. There were limits to how far a black soldier could advance, informal barriers that no amount of demonstrated competence could overcome. But he had proven that expertise mattered, that innovative thinking could achieve what brute force could not, that the most valuable weapon was sometimes knowledge rather than firepower. Captain Thornton's after-action report on the bridge operation was circulated widely through Army engineering channels. It sparked significant interest, particularly among chemical warfare planners, who began exploring other applications of chemical sabotage against concrete and masonry structures. The report carefully credited Corporal Marcus Washington as the originator of the operational concept, which was unusual recognition for an enlisted soldier, particularly an African-American one. Thornton later told Marcus that he had fought hard to ensure Marcus received proper credit, arguing that failing to document contributions based on skin color was both morally wrong and practically stupid because it discouraged exactly the kind of innovative thinking the military desperately needed. The bridge itself became a case study in unconventional warfare, post-war analysis, conducted after Allied forces captured the area and could examine the collapsed structure directly, confirmed that Marcus's chemical attack had worked exactly as theoretically predicted. The soap solution had penetrated deep into the concrete pilings and support structures, initiating alkaline degradation that weakened the material significantly. Combined with the mechanical stress from heavy traffic and the water pressure from spring flooding, the weakened concrete had reached a failure point. The collapse had been sudden and complete, dropping the center span into the river in a matter of seconds. German engineering reports captured later confirmed that their post-collapse investigation had been baffled. They found evidence of chemical degradation, but attributed it to natural processes, perhaps related to industrial runoff or unusual water chemistry. The possibility that this was deliberate sabotage using soap powder apparently never occurred to them. What made this particularly significant was that the entire operation had been accomplished without ever placing Allied personnel at direct risk. Previous attempts to destroy the bridge had required soldiers to approach within direct fire range, often with deadly consequences. The chemical sabotage approach eliminated that risk entirely. The delivery mechanism, floating containers that mimicked natural debris, was essentially undetectable and unstoppable. German forces could not patrol the entire river upstream, could not stop all floating debris without creating their own logistics problems, and had no reason to suspect that innocent-looking logs were actually chemical weapons. It was asymmetric warfare in its purest form, using intelligence and unconventional methods to overcome superior defensive positions. Marcus continued to serve in Italy through the end of the European War, participating in several other operations that utilized unconventional approaches to tactical problems. He worked on a project to contaminate a German fuel depot using a chemical additive that caused engine failures. He helped design camouflaged observation posts using materials that mimicked the thermal signature of surrounding terrain. He consulted on bridge construction projects, bringing his understanding of structural chemistry to bear on making Allied bridges more resistant to sabotage. Each project reinforced the lesson that creative thinking and technical expertise could achieve results that conventional military approaches could not. But the soap powder bridge remained his signature achievement. The operation that proved an unlikely idea could succeed when given a chance. In quiet moments, Marcus sometimes thought about the strange path that had brought him to that moment. A young black man from Detroit who loved chemistry, but lived in a world that offered limited opportunities for that passion. A German immigrant chemist who defied social conventions to mentor someone other people dismissed. A war that created circumstances where conventional wisdom failed and unconventional ideas suddenly had value. A white army captain who was pragmatic enough to listen and advocate for a plan regardless of where it came from. All of these elements had to align for the operation to happen. Change any one factor, and the bridge might still be standing, the offensive still stalled, the war perhaps lasting weeks or months longer. The human cost of war remained a weight Marcus carried. He never learned the exact number of German engineers who were on the bridge when it collapsed. Post-war records were incomplete on that detail. He knew that his success had meant their failure, possibly their deaths. He also knew that the bridge had been supporting operations that were costing lives on both sides, that its destruction had contributed to ending the war sooner, that the alternative approaches would have certainly resulted in Allied casualties, and possibly failed anyway. War presented impossible moral equations with no clean answers. You did what seemed right with the information available and lived with the consequences. That was all anyone could do. After the war ended in Europe, Marcus returned to the United States in August 1945. He was discharged from the army in October with an honorable service record, several commendations, and technical experience that civilian employers found valuable despite his skin color. He returned to Detroit and found work at a larger chemical company, this time in a role that actually utilized his expertise. Over the years, he worked his way up to become a chemical engineer, one of the first African Americans to hold that position in the Michigan chemical industry. He patented several industrial processes, became a mentor to younger black chemists and engineers, and lived to see the civil rights movement begin to dismantle some of the barriers he had faced. Dr. Herman Kleist had survived the war in Detroit and continued teaching Marcus informally whenever they met. Their relationship had evolved into a genuine friendship, two men from different backgrounds, united by their love of chemistry and their shared experience of being underestimated by society. Kleist attended Marcus's wedding in 1947, one of very few white faces in the church, and later became godfather to Marcus's first son. When Kleist passed away in 1962, Marcus delivered the eulogy, speaking movingly about how one man's willingness to see past social barriers had changed his life and, in a small way, had helped change the course of history. Captain James Thornton remained in the army after the war, eventually rising to the rank of colonel. He and Marcus stayed in contact through occasional letters and rare visits. Thornton later wrote a memoir about his wartime service that included a detailed chapter on the bridge operation. He was explicit in the memoir about the racial dynamics that had nearly prevented the operation from happening, noting that the military's segregation policy and unwillingness to recognize black soldiers' capabilities had likely cost the army countless other valuable contributions. The memoir was published in 1968 at the height of the civil rights movement and received attention for its frank discussion of racism within the military. The bridge operation itself remained relatively obscure for decades after the war. It was mentioned briefly in official histories of the Italian campaign, usually in the context of unconventional warfare or engineering operations. The role of chemical sabotage was noted but not emphasized, perhaps because it seemed like such an unusual and non-replicable approach. Marcus's central contribution was acknowledged in military records, but was not widely known outside of specialist communities. That changed gradually in the decades following the war, as historians began to pay more attention to the contributions of African American soldiers and to the role of unconventional tactics in achieving strategic objectives. In 1994, 50 years after the operation, the U.S. Army Engineer School at Fort Leonard Wood held a symposium on innovative engineering operations during World War II. The Soap Powder Bridge was featured as a case study in creative problem-solving. Marcus, by then 73 years old and retired, was invited to speak at the symposium. He gave a presentation that combined technical details about the chemistry and engineering with personal reflections on the experience of being a black soldier whose expertise was initially dismissed but eventually proved valuable. The presentation received a standing ovation from an audience of military engineers, many of whom had never heard the complete story. During the question and answer session following his presentation, a young African-American officer asked Marcus what lesson he hoped people would take from the bridge operation. Marcus thought for a moment before answering. He said, "The lesson is not about soap powder or chemical reactions. The lesson is about the cost of prejudice and the value of keeping an open mind." The military had hundreds of black soldiers with technical skills and expertise that were never utilized because of assumptions about what black men could or could not do. How many other bridge operations never happened because the person with the right idea was driving a truck instead of sitting at a planning table? How many problems remained unsolved because the person with the solution was not in a position to be heard? That is the real tragedy, the talent wasted, the ideas never shared, the potential never realized. The bridge operation succeeded not because I was special, but because a few people were willing to listen despite their own prejudices. Imagine what could be accomplished if that were the norm rather than the exception. That answer captured something fundamental about Marcus's perspective on his own service. He had never seen himself as exceptional, just as someone who had acquired useful knowledge and been given a rare opportunity to apply it. The real problem was not the lack of capable people, but the systematic barriers that prevented capable people from contributing. The bridge operation had succeeded because those barriers had been temporarily overcome by pragmatic officers more interested in results than in maintaining social hierarchies. But temporary was the key word. After the immediate crisis passed, the old barriers had largely reasserted themselves. Marcus had been fortunate to find post-war employment that utilized his skills, but he knew many black veterans who had returned from the war to face discrimination and limited opportunities despite their service and demonstrated capabilities. The symposium marked a turning point in how the bridge operation was remembered. Over the following years, it was featured in several books about World War II engineering operations and unconventional warfare. A case study was developed for use in military academies, examining both the technical aspects of the operation and the organizational dynamics that had nearly prevented it from happening. Marcus was interviewed multiple times by military historians and journalists, each conversation adding more detail to the historical record. He always emphasized the collaborative nature of the operation, the contributions of Captain Thornton, Corporal Rousseau, Private Chen, Sergeant Hayes, and others who had helped turn an idea into reality. But he also did not shy away from discussing the racial barriers he had faced and the broader implications for military effectiveness when talent was systematically underutilized. In 2003, at age 82, Marcus attended a ceremony at Fort Leonard Wood, where a training facility was named in his honor. The Marcus Washington Chemical Engineering Laboratory would be used to train military engineers in unconventional approaches to tactical problems. During the dedication ceremony, a three-star general spoke about how one man's innovative thinking had contributed to shortening the war and saving lives, how that man had overcome prejudice and limited opportunities to make a significant contribution, and how his example continued to inspire new generations of soldiers to think creatively and to recognize that valuable ideas could come from unexpected sources. Marcus gave brief remarks at the ceremony, his voice still strong despite his age. He thanked everyone present but also took the opportunity to challenge them. He said, "Naming a building after me is a nice gesture, but the real honor would be creating an organization where people like me do not have to overcome barriers in the first place. Every moment spent fighting prejudice is a moment not spent solving problems. Every talented person excluded because of skin color or background or other irrelevant factors is a problem that remains unsolved. You honor me today, but honor me by doing better than the army I served in, by creating institutions where expertise is recognized regardless of where it comes from, where innovative ideas are evaluated on their merits rather than on the rank or race of the person proposing them. That would be a fitting tribute." The speech was reported widely and resonated with ongoing discussions about diversity and inclusion in the military and broader society. Marcus had touched a nerve, using his own experience to illustrate a point that many people understood intellectually but struggled to implement practically. Organizations said they valued innovation and diverse perspectives, but they often maintained structures and cultures that systematically excluded certain voices. Breaking down those barriers required more than good intentions. It required deliberate effort to listen to people who were typically overlooked, to evaluate ideas based on merit rather than source, to create pathways for talent regardless of where it originated. Marcus Washington passed away in 2007 at age 86, surrounded by family in the same Detroit neighborhood where he had grown up. His obituary appeared in major newspapers, highlighting his wartime service and his later career as a pioneering chemical engineer. The bridge operation was featured prominently in these obituaries, described as an example of ingenuity and courage that had contributed to Allied victory. But Marcus himself might have preferred a different emphasis. His life's work, both during and after the war, had been about demonstrating that capability existed in unexpected places. That prejudice was not just morally wrong, but practically stupid, that organizations that failed to utilize all available talent were handicapping themselves unnecessarily. The Soap Powder Bridge has become, in the decades since the war, something of a legend in military engineering circles. It appears in textbooks and training materials as an example of unconventional problem-solving. The basic story, a black private who used chemistry to accomplish what multiple commando raids could not, has a narrative appeal that makes it memorable. But the deeper significance lies not in the specific tactics, but in the broader lesson about organizational effectiveness and the cost of prejudice. The bridge operation succeeded because specific individuals, Thornton, Havisham, and others, were willing to temporarily set aside the military's racial hierarchies and listen to expertise regardless of its source. That willingness was unusual enough in 1944 to be remarkable. The question that Marcus posed repeatedly in his later years was why it should have been unusual at all. Modern military doctrine emphasizes the importance of innovation and creative thinking in addressing complex challenges. The bridge operation is frequently cited in discussions of unconventional warfare, asymmetric tactics, and the value of technical expertise in military operations. What is sometimes overlooked in these discussions is the social context that made the operation noteworthy in the first place. The tactics were innovative, yes, but the more fundamental innovation was allowing a black enlisted soldier to contribute technical expertise at the planning level. That should have been routine but was instead exceptional. The real lesson of the Soap Powder Bridge is not about chemical reactions and concrete degradation. It is about the immense cost, measured in unsolved problems and missed opportunities, of any system that fails to recognize and utilize available talent. The bridge itself was never rebuilt. After Allied forces captured the area in April 1945, they constructed a temporary crossing at a different location. The original bridge site was left as it was, the collapsed span partially submerged in the river. In the decades after the war, the area became agricultural land, with no marker indicating the historical significance of the location. Only old maps and military records documented what had once stood there and how it had fallen. In a sense, this anonymity was fitting. The bridge's destruction was important precisely because it was unspectacular, achieved through patient chemistry rather than dramatic explosions, the result of careful planning rather than heroic charges. The soap powder operation worked because it avoided the conventional narrative of how bridges are destroyed in war. It was quiet, subtle, and devastatingly effective. That quiet effectiveness, more than any monument could, captured Marcus Washington's contribution to the war effort. Looking back from the perspective of 8 decades, the Soap Powder Bridge operation stands as a small but significant moment in military history. It demonstrated that technological superiority was not just about having better tanks or aircraft, but about fostering organizational cultures that could identify and utilize expertise wherever it existed. It showed that strategic objectives could sometimes be achieved through patient chemistry rather than immediate force, and it highlighted the human dimension of war, the fact that technical knowledge and creative thinking could save lives by providing alternatives to high-casualty frontal assaults. These lessons remain relevant, perhaps more so now than ever, as military organizations grapple with increasingly complex challenges that cannot be solved through conventional approaches alone. Marcus Washington's journey from truck driver to decorated engineer specialist to pioneering chemical engineer embodied both the possibilities and limitations of his era. He had been given an opportunity, however reluctant and limited, to demonstrate his capabilities. He had seized that opportunity and proven that talent and expertise transcended racial categories. But he had also experienced firsthand how prejudice created barriers that prevented many others from having similar opportunities. His later advocacy for diversity and inclusion in technical fields was grounded in this experience. He knew personally the cost of being underestimated and the value of being given a chance. He spent his post-war career trying to create more chances for others, mentoring young black chemists and engineers, advocating for fair hiring practices, challenging organizations to evaluate people based on capability rather than assumptions. The soap powder bridge operation was remarkable, not because it involved an extraordinary individual, but because it represented the potential that existed in thousands of ordinary soldiers whose talents were systematically ignored. For every Marcus Washington who managed to contribute despite the barriers, there were likely dozens or hundreds of others whose knowledge and ideas were never heard. The military effectiveness question was straightforward. An organization that utilized all available talent was more effective than one that arbitrarily excluded large portions of its human resources. This should have been obvious, but prejudice is rarely rational. It took until 1948, 3 years after the war ended, for President Truman to issue the executive order desegregating the military. And it took several more years for that order to be fully implemented in practice. By that time, countless opportunities for innovation and effectiveness had been lost to prejudice. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Do not forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.